Here we will discuss about recursive functions using Raptor. I am Dr. PV Sena from CBIT. So what is a recursive function? A function which is called itself is said to be recursive functions. A function self-calling. A function which is called itself is said to be a recursive functions. Suppose if I want to find n factorial. So n factorial is equal to n into n minus 1 factorial. So I am calling this fact function by passing n minus 1. Right? So a self-calling is a function which is calling itself is said to be a recursive function. Already you know the simple mathematics, 0 factorial value is 1, 1 factorial is 1. So n factorial is equal to n into n minus 1 into n minus 2 into up to so on 2 into 1. In recursion, n factorial is equal to n into n minus 1 factorial. Already you know that a function which is calling itself is said to be a recursive function. Suppose my input n is equal to 5. The output is 5 factorial value becomes to 120. So the logic behind of this one is, so the base conditions are initial conditions. Here it is n is equal to 1 are written 1. If n is equal to 0 or n is equal to 1, written 1. So other cases, otherwise return n into the given number into factorial of n minus 1. So I am calling the same function by changing n minus 1 parameters. The parameter is every time decremented by 1. So the basic symbols used in this video is including this input output symbol and processing. So we are calling this function calls. So I'm using this function call factorial function call by passing n minus 1. So this is my input parameter. The output parameter is this fact. So this every time this fact variable is multiplied with n into the given factorial of n minus 1. Here this is my basic symbol here we are using. If n value is 0 or n value is 1, simply we are returning 1. If n value is not 0, neither 0 nor 1, then we are calling n into factorial of n minus 1. So n minus 1 is here, it is my input parameter, fact is the output parameters. So here n is the input parameter, fact is the output parameter. My function name is the factorial. In factorial algorithm using recursions. So in this we are passing n, my input parameter n, integer where n is greater than or equal to 0. So this is positive integer. The output is the factorial of n denotes as n factorial. So steps. So first step is if n is 0 or n is 1, then return 1. This is the base condition. Otherwise return n into factorial of n minus 1. So again, I'm calling this factorial function by passing the parameters n minus 1. So this is a self-calling this factorial. Suppose if you are passing n value is 3. So first time 3 into factorial of 2. So next time is so 2 into factorial of 1. So factorial of 1 will returns 1. So 1 into 2 into 3. This becomes to 6. Then the algorithm. So now the flow chart of n factorial using recursion. This is the diagram, flow chart, pictorial representation of our n factorial diagram. So start this program, enter n value, factorial. I'm calling this factorial function by passing n value. Here res is the output variable, n is the input variable, res is the output variable. So put the value here it is, and so now here start. I'm calling this start. The factorial function input parameter is n, output parameter is fact. Fact is equal to 1. If n is 0 or n is 1, fact becomes to 1. In other case, factorial, I'm calling this factorial function by passing n minus 1 as input parameter. Fact is the output parameter. Every time I'm updating this fact is equal to n into fact. Here we can write, so n into fact here also that output parameter, else you can take a special assignment variable. Fact is equal to n into fact. Every time I'm calling this factorial function by decrementing n value. This is my output. So here I'm calling 5 factorial value becomes to 120. I'm passing 4 factorial 24. If I'm passing n values to 2 factorial is 2. n value is 1, 1 factorial is 1, 0 factorial is 1. So now if n value is 0 or 1, then we are returning the fact value is 1. Otherwise, we are calling this factorial function by incrementing n value. So n minus 1 is the input parameter, fact is the output parameters. So this is my expected output. In this way, you can try this problem, the sum of first n natural numbers using recursions. So previously we call this the factorial of the given number. If you need the sum of first n natural numbers, in this case, in place of star, you need to use plus n plus fact. N plus fact, it will give the sum of first n natural numbers using recursion. So the Fibonacci sequence f of n is equal to f of n minus 1 plus f of n minus 2. With the base condition f of 0 is 0, f of 1 is 1. So f of 0 value is 0, f of 1 value is 1. So next f of 2 value becomes 2, 0 plus 1, 2. Right? F of 2 value becomes to 0 plus 1, that is becomes to 1. F of 3 value becomes to 1 plus 2, 1 plus 1 becomes to 2. So just adding the previous two numbers, we are getting the next number. So this is f of n is f of n minus 1 plus f of n minus 2. So this f of function is defined with the same function f with the n minus 1 parameter, the same function with the f with n minus 2 parameters. So these are said to be Fibonacci sequence. So by changing the parameters n minus 1 and n minus 2. Suppose if we find out the sum of individual digits 1, 2, 3, 4, the given number is 1, 2, 3, 4, 1 plus 2 plus 3 plus 4. So then power of n number exponentials. So compute x to the power of n where x value base and n is the non-negative exponent. So x to the power of n using recursion, reverse a string raise. So the given string is Madam, M-A-D-A-M, or Malayalam, or Liril. Then you need to reverse it. Even the reversed string and the given string is equal, then we can say that it is the palindrome. So greatest common divisor GCD by using recursion. Find a maximum element in an array. Maximum element you can find by using this recursion. Towers of an eye problem. This is very important in recursive problems. So these are the basic problems you can try. Thank you, children. Thank you for listening.